Yes, good morning, everyone. So, in the last class, what we have discussed regarding IPv6. Okay, types of IPv6, static routing using IPv6, then default routing, and after that, we have done stateless auto configuration, and even we have discussed regarding EUI, that is extended unique identifier. Clear that part? And NTP we have discussed at the last. Okay. So, see here, we will take one scenario. This is a switch. And with this switch, we have connected here multiple PCs. This is PC1. This is PC2. This is PC3. And this is PC4. Now, you know that if, let's say, for example, PC1 wants to communicate with PC4. So what will happen? This PC1 is going to send this message to the switch. Now, the switch does not have the information about the PC4. First, let's say it is going to have IPs also, 10.0.0.1, then 10.0.0.2, 10.0.0.3, and this one is 10.0.0.4. Now what happens that here PC1 wants to communicate with PC4. So all the PCs having the IP addresses. Now you know that if they have to communicate in the local area network, so what they required? MAC address. Because at layer 2, what communication on what basis the communication will take place? MAC address. So PC1 will send this information to the switch. Now the switch will tell that I don't know the location of the PC4. So what this switch is going to do? Broadcast. That we call it as a unicast flooding. Okay. When this message will reach to the PC4, it will come to know that this is my IP. It means I have to respond. So PC4 will respond. So in this, we will be having one ARP request and ARP reply. So what happens with a single switch if I am having four PCs? So if PC1 is trying to communicate with any other PCs, then broadcast will happen, and all the PCs is going to receive that particular broadcast message. Correct? This happens. Now let's consider what happened. That these two PC belong to one separate department, and these two PC belong to one another separate department. No, no, wait. Let's consider this is sales department and this is finance, or you can say IT, we can say. Okay. Now it means here what happens that this switch is located in one single organization, and that organization is going to have multiple end devices, multiple PCs. Now all these PCs is of same organization only, but they belong to different departments. So one is like this two is for sales and this two is for the IT department. Now you know that if this PC1 is trying to communicate with, let's say, PC2, if we have not distributed it or we have not divided it, then what will happen? PC2 will not receive it directly. Broadcast will happen. PC3 will receive and PC4 will receive in a normal scenario. But as we are dividing it, so what we want that when PC1 is trying to communicate with PC2, broadcast should happen, but it should not go beyond my department. Okay. this message should not be delivered to the IT department. Same if PC3 and PC4 is communicating, this message should not be delivered to the sales department, right? So what you are doing it, you are dividing the large broadcast domain into the multiple smaller broadcast domain. Now here what will happen? Let's say if you have taken one more PC here, PC5, this side. So if this PC5 and PC3 does not know about the 5, so what will happen? That PC3 will send the ping message, then switch will broadcast. Now this broadcast will happen only in the same department. Getting my point? Single switch, but what we have done, we are breaking the broadcast domain into the multiple small broadcast. So how you're breaking this? Using a concept called as a VLAN. What is VLAN? Virtual Local Area Network. Right? Now in this what happens? In the VLAN, large broadcast domain is divided into small broadcast domain. Correct? Into multiple small broadcast domain, we can say. Correct? No? Then what it gives? It gives you controlled access to the network. Right? It makes network secure. How? See, as unnecessary traffic is not flowing to other departments, that's why we can say it is going to make it secure only, right? Now, see what will happen that here, when you are trying to use this VLAN, then here you have to write VLAN numbers. See, by default, if you will take a single switch, with that, let's say 50 PCs are connected. So all that 50 PCs will be part of what? Single broadcast domain. And if it is a single broadcast domain, that is called as a single VLAN. It means VLAN number one. So by default, switches will be having VLAN 1. In that, all the ports connected will be part of VLAN number 1. But if you want to have different VLANs on the same switch, for that you have to create different VLAN numbers. So for example, if I'm having a sales department, so here I can write what? Let's consider VLAN 10. And this one as a VLAN 20. Correct? So if I have given here VLAN numbers, so broadcast will happen, but it is going to happen only in the same VLAN, not in the different VLAN. Correct? So see what it is written here. That it says VLAN is logical grouping of devices within the same physical network that communicates as if they are not, if they are in on their own independent network. Means they are in the same network. Network address will be same, but that too also network address is same. Devices will not be able to communicate outside its department or outside its VLAN. Now in this scenario, what will happen? Let's say you have divided into different VLAN, right? Here we have 10 and 20. So this PC1 will be able to communicate with this PC2. PC3 will able to communicate with PC4, but PC1 and PC3 will not be able to communicate, right? So we can write here one more point that devices in different VLAN does not communicate. Devices in same VLAN will communicate and devices in different VLAN will not be able to communicate. Extra point, we can write it here. To enable the communication between the devices located in different network or different VLAN, inter-VLAN will be used. Right? So to enable the communications between the devices in different VLAN, what is used? Inter-VLAN. VLAN is logical grouping of devices. So see, what we are doing here, everything is logical, no? You're not taking like a cable and binding the multiple devices in a single department, not like that. Logically, it is correct. Then what it says, it enables the segmentation of network traffic. How? It enables what? Segmentation of network traffic, right? So traffic will be circuited inside the same VLAN, not in a different VLAN. That is going to enhance what? Security, reducing the broadcast traffic and optimizing the network performance. So in short, we can say that it VLAN reduces the broadcast domain size and improve network efficiency. And it facilitates network management by grouping devices logically rather than physically. Here, devices are logically bundled and it is going to be kept in a single particular VLAN. Correct? So what it does, it reduces the broadcast traffic and broadcast domain size. Reduces broadcast traffic and broadcast domain size. Okay, now what happened that let's say this is one floor of our organization. Here we have four PCs. Now this switches was having limited number of ports, but I was having more numbers of end devices. So for connecting my rest end devices, I need to take one more switch. So one more switch. This is switch 2 now. Here also I have taken certain end devices. This is PC5, PC6, PC7, PC8, and this is going to be PC9. We can consider here that this first three PC is a part of one department, same, that is going to be sales. And the last two is in the IT department, right? So we have to mention here that this is what cells, and this is going to be IT department. Okay. Now, why we have taken one more switch? The reason we can say that as switch one was having limited number of ports, so I was having more numbers of end devices. So I have to take one more switch to connect my further more end devices, right? That's why I have taken one more switch. So this particular cells department I have given VLAN number as what? VLAN 10, and this one has VLAN number 20. Now, here also we have a cells, here also we have a cells. Now, you can consider that both the cells department is of same organization, but what is the differences? We can say it is on one first floor, it is on the second floor, like that we can consider. Now, if they belong to a same organization, they have to communicate. It means PC1, PC2, PC5, PC6, and PC7. All this PC has to communicate. But when they will communicate, that message should not be delivered to the PC3, 4, and PC8 and PC9. So for that, what is required? Again, VLAN, and what we are doing here, logical segmentation. Okay, so between these switches, we should have one connectivity, right? So when any PC1 is trying to send the traffic to the PC5, what will happen? This message will reach to the switch. Now, this switch has to identify that this particular information is coming from VLAN number 10. Then I have to forward this information to VLAN number 10 only, right? So what it will do? It will send the traffic to the switch 2, and switch 2 will come to know that this information is coming from VLAN number 10. I have to send it to the VLAN number 10 only. So broadcast will happen. In this scenario, PC5 will receive, PC6 will receive, and PC7 will also receive for the first time when broadcast happens, right? But 8, 9, 3, and 4 is not going to receive that. Correct? Getting my point? So how you tell this switch that this PC is a part of VLAN number 10? How you will inform? Based on the port numbers. Okay. So what will happen there? That let's consider this is a port number F01. This is port number F02. So we will be informing the switch. This is going to be F02. So it means that we have to inform the switch that on this interface F0/1, we have a PC, and this PC is a part of VLAN 10. Same as you will inform F02, we have a PC2, and this is a part of VLAN number 10. Same, this is F03, so we have a PC3 that is a part of VLAN number 20. So with the help of this port, this switch is going to come to know about the devices and its which VLAN, right? Now, here also we will be having a port number. Let's consider this is F05, and this side also we have F05. Right? So what we have to configure here? Now we'll understand the ports of the switches. See, we have one access port. Which port? Access port. The port by which end devices are connected is called as access port. The port through which or by which end devices are connected. Right? That is called as what? Access port. An access port carries single VLAN information. So here, as F01 is also a port, so this is a which type of port? Access. By end devices are connected with this port. Correct? No. And when this end devices will communicate, it will send a VLAN ID. And with this F0/1, which VLAN ID is associated? VLAN 10. So one port, one single VLAN. Correct? No? That's why it says that it is going to carry what? Single VLAN information. Now, for example, if let's say PC1 is trying to communicate, so PC1 will communicate, this switch will come to know that, okay, this PC1 is communicating, this is associated with F0/1, and this is a part of VLAN 10. That is fine. When this information will come to F05, it will send it to switch 2, and switch 2 will again send this information to the VLAN 10, right? Same as if PC3 is communicating, so PC3 is a part of which VLAN? 20. This information will be delivered to whom? Again, VLAN 20 of IT department of different switch, like here, second switch. So it means that this F05, when it is getting the information from 10, it is sending to the 10. When it is getting from the 20, it is sending to the 20. It means that this port is carrying multiple VLAN information. Correct? No? Carrying? No? What it does? It carries multiple VLAN information. So that is called as a trunk port. So the port between the switch or between switch and router carries.
You wrote same thing 2 times. Between the switch or between the switch.
Okay, between the switch or router carries multiple VLAN information. Between the router means we can have a switch also, a router also. No, switch or router. There also we can do this trunk. That will be helpful when we will be doing the Inter-VLAN. Fine. So it means we will be having one access port where the end devices will be connected, and we will be having one trunk port between the switches that has to carry multiple VLAN information. No. This will be called as a trunk port. Both sides will be trunk. There is also certain condition. We'll come to that part. Okay. Now, every time we are telling, okay, we will assign one VLAN ID. So what will be the range of the VLAN ID? That we have to write to VLAN 10, VLAN 20, VLAN 30. So what is that number range? So total number range for this VLAN is VLAN number 0 to 4095. But we will not be able to use all this VLAN number 1. Okay. So what it says that these are reserved VLAN which cannot be used, or we cannot see, or we cannot use this. Which VLAN? 0 and 4095. Particularly VLAN number 0 and VLAN number 4095 is not being used. So what will be used? Only VLAN number 1. Now, from 1 to, first thing is VLAN number 1 will be used, but this is called as what? Default VLAN. Again, it means that this is a default VLAN, so I cannot assign my devices or my one VLAN as a VLAN number 1. The reason, already it is present there. So I have to use from where? From 2. right? So it says that it has been further divided, like from VLAN number 2 to 1001, 2 to 1001, and this VLAN range is called as what? Normal VLAN range. We can create this, edit these VLANs. Okay. Among that also, after this 1001, from 1002 to 1005 is again reserved. We'll explain you why it is reserved. And then from VLAN number 1006 to 4094 will be used, and this is called as a extended VLAN number range. Okay. Now, why this VLAN number 0 is reserved? VLAN 0 is reserved for quality of services. Okay. VLAN 0 is reserved for quality of services. Then VLAN 4095 is reserved for virtual machines. Okay. So this cannot be used. So what can be used from 1? But again, VLAN number 1 is what? Default VLAN. VLAN 1 is default VLAN. That's why we will be using from 2 to 1001. Okay. So VLAN 2 to 1001 can be used. And this is called as what? Normal VLAN. Okay. Then VLAN number 1002, 1003, 1004, and 5 reserved for token ring. And FTDI. Token ring and FTDI, they both are older technology, now not now preferred. But that too also, these ranges are reserved. Okay, but when you will have this new devices, new switches, again it can be used, but as of now, these are reserved numbers for the token ring and FTDI. So what is token ring? It is a older technologies where devices used to get connected logically like a token ring structure. I'm not telling physically, logically, like a ring structure, where Bedal put this token passes, what will happen? Each devices get a chance to send the traffic, to send the data information. Okay, but the we'll come to that part. So in token ring, the speed that we get is maximum around 16 Mbps. Okay, 4 Mbps till 16 Mbps. It means it was slow, right? Same as we have FTDI, that is called as a fiber distributed data interface. Here also we were having a logical ring structure, but in this it was of 2 layers, right? Here we were having 2 layers of logical structure. Like what? Like one is primary and one is secondary. So primary is responsible for sending the traffic. If primary is not working, is not available, then secondary will send, and that's why it was used for a backup purpose, or we can say as a redundancy. But this was also providing the maximum speed of around 100 Mbps. That's why it has been replaced. Token ring and FDDI has been replaced with what? Ethernet. And Ethernet provides you the speed of 10 Mbps, 100, then 1 GB, 10 GB, like that. Okay. Apart from that, it was also a little complex, token ring and FDDI. But FDDI compared to token ring provides faster speed, where we can use this fiber optic cables as well. Correct, no? So that's why these ranges are reserved. So what we will be using here only from 1002 2 to 1001 and from 1006 to 4094. Correct? So total VLAN number is what? How many? Total VLAN number 0 to 4095. It means 4096. I am starting at 0, ending at 4095. So how many I will get? 4096. Correct? So you have to remember what all the VLAN numbers are reserved and for what it is reserved. Is it clear? Now, one more thing we can conclude here, that first we had this normal VLAN range, and later on we had this again extended VLAN number range. Getting? So first, what we were having, normal VLAN number range, and then later on what we had, even extended VLAN number range. Clear till here? Got the idea? So now whenever we'll configure, we will be preferring this now normal VLAN number range. Okay. So just you can write it here, usable VLAN number range. So usable VLANs are 2 to 1001, and this is called as what? Normal VLAN range. And one more is from 1006 to 4094, and this is called as a extended VLAN range. Now see. So here also we have this as a switch port. So a switch port is a physical interface or a network switch that enables devices to connect to the network. Means what is switch port? The physical interface through which the devices can get connected to the switches, right? Now we discussed that it is going to have two. One is access port and one is called as what? Trunk port. So access port is used to connect end devices like computers, printers, and IP phones to the network. And this port are the part of what? Single VLAN. Then trunk port, it allows multiple VLAN to pass through a single port. And these are used to connect switches to each other or to the routers. And it will carry multiple VLAN information. Correct? No? Now, what happens? That, okay, fine, that it is going to carry my multiple VLAN information, trunk port. Then how it is going to identify that this particular information is a part of VLAN 10 only? How it will send? See, what happens? Let's consider that you have taken here layer 2 switch. So layer 2 switch means what? It is completely operating on a layer 2 of a OSI model. That is called as a data link layer. Now you know that at data link layer, the communication will happen only in the same network, right? It cannot happen in the different network. Okay. So when you are having a layer 2 switch, By default, you know that layer 2 is having the capacity to enable the communications in the same network. So if it is having the capacity to enable the communication in the same network, that's why tagging in layer 2 switch is not required. What is not required? Tagging is not required. Okay, we'll come to that part. What is tagging? Whereas if you have taken here layer 3 switches, we also have layer 3 switch. Okay, that will be acting as a switch only, but it can enable the communications between the devices located in a different network. Now you know that this layer 2, layer 3 switches has the capacity to enable the communications between the devices located in different network. But I want that it should not enable the communication between different network. So what is required here? You need to control this, no? You have to specify, you have to give information to the layer 3 that see you don't need to enable the communications between different network, right? So on a layer 3 switch, we will be doing this tagging. Understanding? Got the point? Consider here, like let's say we have a highway, national highway. Okay, we have different lanes, no? So all the vehicles will be running on the different lanes. Now it is said no that okay, the heavy vehicles will be running on the left, then the faster will be running on the right. Now you know that if the in a normal scenario, if every person is very obedient, okay, we know that he will not keep changing his lane. So there will be no any requirement for any monitoring tools, right? No, correct? No, it is not required. But we know that they will keep changing the lanes. So that's why a specific rule is required. It is told, okay, you follow this rule only. Why? Because we know that these persons are notorious. They will not follow the rules. Same as we can consider here layer 3 switch as a like that only. He will not follow the rules. For that, we need to specify, okay, that you don't have to send the traffic outside your own network. And that's why here tagging is required. So where tagging is required? Layer 3 switch. Okay. So when will you use a layer 2 switch? In the command, you will give only one thing, switch port mode trunk to form the trunk. For the trunking purpose, you will give interface number, and switch port mode trunk. Whereas in the case of layer 3 switches, you need to give encapsulation.1q also. Tagging. Tagging means what? Whenever any information is coming from any particular VLAN ID, it has to know that this is coming from VLAN number 10. I have to send it to VLAN number 10. That's all. And this is like a tag, pasting a information where in the header information. Getting my point? No, no problem. We'll discuss with configuration. Let me show you the first thing, how to enable the communication between the devices in a different VLAN connected with a single switch. Okay. Then we'll come to the tagging part. Example was good. Highway example. See here, we have taken one switch, and with that PCs 1, 2, 3, and 4, and 5 PCs will take. Okay. See the interface numbers are visible, right? F01, F02, F03. Port numbers F04 and F05. Now we have to give the IPs also. This is 10.0.0.1. This is 10.0.0.2. This is what? 10.0.0.3. Then this is going to be 10.0.0.4, and this is 10.0.0.5. So all these PCs belong to a single network. But what we will do, that first three PC is a part of one VLAN. So consider here that these two PCs are part of VLAN number 10, and this is VLAN 20. Right? Now, first you configure the IPs on the end devices. Come to desktop, IP configuration 10.0.0.1. Now here default gateway is not required because we have to communicate in our own network only. Then come to second PC, 10.0.0.2. Ten dot zero dot zero dot 3, 10.0.0.4, and 10.0.0.5. Now see with simulation what happens. Like first we'll not configure any VLAN, just we will see how the traffic is being flowing here. So when you will try to ping, come to command prompt and try to ping to 10.0.0.4, right? So if you will see here that we have two packets, one is what ARP and one is what ICMP packet. So first what will be delivered? ARP. Delivered to the switch. Now see what the switch will do? Broadcast it. So this information is being broadcasted to the VLAN 10 also, VLAN 20 also, right? And which side we have this 0.4 PC in a VLAN number 20 side. Okay. Now if we will configure here VLAN, then what will happen? This broadcast will not happen. Broadcast will happen only in the same VLAN, not in the different VLAN. So for that, we need to configure on the switch. Enable configure space T, give a host name now as a S1. See, here you can individually also assign that, okay, interface F01 is a part of VLAN 10. Or as you know that here we have interface F01 and F02, both are the part of VLAN number 10. So we can go with the range also, range command. By default, you know that, okay, I will give you an interface F01, right? And then I will write that this is a part of what? VLAN number 10. But as I know that, okay, one more interface is there that is a part of VLAN number 10. So why to go with this one by one? Better to go with what? Range command. So how will you give that range? Interface range. Interface range, then F0 slash 1 hyphen 2. Because from 1 to 2, if I'm having 1 to 10, then I will give 1 to 10. It means in that 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All are the part of what? VLAN number 10, like that. Given. Then we have to configure here first switch port mode access. Switch port mode access. Then switch port access VLAN. Switch port access VLAN, right? But wait, if you are writing here VLAN directly on the interface number, don't you think that there is certain missing point? What is missing here? Directly what I am writing, that this interface is a part of this VLAN. Before that, you have to do one more point. First, you tell the switch that what all the VLANs you have apart from VLAN number 1. So you will tell that you have VLAN number 10. Before coming to this command, first you have to specify what all the VLAN information this switch is having. One is what? VLAN number 10. Then this VLAN number 10 belong to which department? Sales department. Name is what? Sales. This is not mandatory. It is not mandatory to write the name. It is optional. Okay. Then one more VLAN we have. What is that? 20. And what is the name? Done. Now give exit. And now you give interface range F0, 1 to 2. Then what command I will give? Switch port, mode, access, then switch port, access, VLAN. Which VLAN? 10. Done. Give exit. This command we are giving to make this port to act as an access port. An access port will carry what? That's why. But this command is also not required. A step by step, I will come to each point. Okay. So we have given a switch port access VLAN number 10. Then interface range from F0, 3 to 5, because 3, 4, and 5, 3 interfaces. Switch port, mode, access. Switch port, access, VLAN, 20. Done. So we have informed the switch also. For the first time, what we have informed, that you have VLAN number 10 and VLAN number 20 with these names. Then we have informed it that this is the interface number that belong to VLAN number 10, and these are the interface number that belong to VLAN number 20. Give exit and give command do show VLAN brief. Do show VLAN brief, and now you see what all the VLAN information we have. What is the first one? Default VLAN. So it means all the ports is the part of what? VLAN number 1. But now only we have divided into multiple different ports, multiple different VLANs. That's why here it is telling you that VLAN number 10 with name as a sales and is having these two interfaces, F01, F02. VLAN number 20, IT as a name, is having 3 interfaces, F03, F04, and F05. So all these interfaces from F01 to F05 earlier was a part of what? VLAN number 1. But now we have divided into 10 and 20. So one single broadcast domain has been further divided. Correct? So how many VLAN exist here? Number 1, 10, 20. And apart from that, we have that is called as a reserved VLAN, FDDA and token rate. Right? Now, again, we'll try to do simulate. Okay. Now, ping to 10.0.0.2. It means I want to ping to the devices in my same VLAN. Okay. Now, RP is there. Now see what will happen. Deliver to the switch. Where it is delivered? Only in the VLAN number 10. Right? It is not sending the information to the 20. Even for the first time they are communicating. ARP is required here. ARP request is there. The ARP request is in the broadcast form. But broadcast will happen, but in the same VLAN. You can see this when we will try to ping it from this particular PC to the last PC. Ping to 10.0.0.5. Here also, ARP is there, right? Then see what will happen. Deliver to the switch. Broadcast is happening. Yes, it is happening. But where it is sent? In the same VLAN, not in this VLAN, right? And it is dropping this packet because this is not the IP addresses. This is the IP address. It will reply. It will reply. and message will be delivered to the specific device. Clear? Now, if you try to ping from first PC to the fourth PC, let's say 10.0.0.4, what will happen? It will ping? No, it will not ping because they are in the different VLAN. Correct? No? Hmm. It considers like that only. Right? We'll take one more switch. Then we'll take here 4 PCs. See, these are the layer 2 switches. Okay, both the switches that we have taken here is layer 2 switch. Okay, now first come to the second switch, CLI, enable config space T, host name will be S2. Now, first what we have to give here, VLAN information. VLAN number is what? 10. Name is what? Cells. Set. Then VLAN number 20. Name is what? IT. Done. Then we have to inform regarding the interface number and with that associated VLANs. So here we have F01 and F02. So what command I will give? Interface range F01 to 2. Switch port mode access. Then switch port access VLAN 10. Then interface number F032 4. Switch port mode access switch port access VLAN 20. Done. Now we have informed regarding all these interfaces, right? What about this one? What this is? Trunk port. Okay. So for this trunk port, where we'll do this configuration on the interface number F05 of the switch, we can do it on any side, either on this side or on this side. Let's do it on this side. Interface. No, by default, it's not trunk port. By default, it will be in the access only. Okay, how will you verify? Give exit show interface F05. Show interface F05 and give here switch port. So interface number, switch port. What it says. What is the mode? Static access. What is the admin mode? Dynamic auto. Okay. So by default, the switch port will be in the access only, where it is going to carry single VLAN information. That's why I told you that the command that we give, switch port mode access, is not required. By default, it is in the access only, no? Right? Now we have to do here trunking. So what is our port number? F05. For that, we'll give command switch port, mode, and trunk. Switch port, mode, trunk. Now give exit. Again, you verify, show interface F05 switch port. What is a port? Trunk. It is trunk. Okay, have you configured trunk on this interface F06? We have not configured now. Up to the switch. Give exit. Show interface F06 switch port. Not by default. Other side, we have configured trunk that will negotiate with other port to automatically form the trunk. Getting one side we have configured the trunk, other side we have not configured the trunk, but this is also becoming automatically trunk. Why? Because if I have configured trunk, so this will tell this interface to form trunk. I am trunk, you also become trunk. Like this you can consider. And this happens because of one protocol that is called as a dynamic trunking protocol, DTP. Once we complete VLAN, inter-VLAN, we'll discuss DTP, dynamic trunking protocol.
Sir, if any other switch is also connected, third switch, that will be also.
No, it should be always between directly connected. Okay, because these ports F06 and F05 are directly connected. No, that will not be directly connected. That will be other side. So it is going to form trunking between them. So if you have configured here, it is negotiating with him to form trunk. That you can consider. Right? And by default, trunk carries what? Multiple VLAN information. So based on this trunking, now you first assign the IPs to the PCs. Ten dot 0.0.6. Ten dot 0.0.7. Then now see with the simulation mode. Come to this PC1. What we will do, we'll try to reach PC on this one, 10.0.0.6. Give enter. See, we have one packet ARP. See what will happen. Delivered to the switch. Then see, in this scenario, it is sending this information to this also, because this is also part of VLAN number 10. And then further, it is sending it to the this switch. Now what will happen? It will send it to only VLAN 10, not to VLAN 20. See, deliver to 10 only. It means 20 is not receiving because trunking has been done. Okay, and even it is layer 2, that's why tagging is not required here. By default, it will send the traffic only to the same VLAN. It means same network because this is a layer 2 switch, right? No? The reply you will get. Understood this? So it is pinging here. Clear? So first we'll write the command, then we'll start with the tagging part. First, what we write? VLAN. Then what we write? VLAN ID. Then we write here name. Later on. Name. Then interface range. And let's consider F0, 1, 2, 5. Example I'm giving. Switch port, mode access, and switch port access VLAN, and that particular VLAN ID we have to write. Okay, for trunking purpose, interface, interface number, switch port, mode, trunk. With the help of series of the switches. Clear till here? Yes, all guys, clear till here? Please confirm.
Sir, while our packet goes to the different switch, if there is no VLAN 10, what will happen?
If there is no any VLAN 10, then what will happen? This information will be reaching to the switch, but this switch will not forward this information. The reason it is only forwarding when it knows that I have VLAN 10 connected with me. As where we are having here 10 and 20 also. So what happened? It was sending it to only to the 10, not to the 20, right? So if we don't have 10 and 20, it will not send only. That message will be dropped. Got?
Yes, sir.
Now see what happens with the tagging. So it says here that trunking facilitates method used in computer networking to allow multiple VLANs to traverse a single physical link between the switches or between a switch and the router. Correct? It facilitates what? Inter-VLAN. It means that it is not only that trunking will be allowed when you have to have the communication in the same VLAN. Even it is required, it is important when we will be using inter-VLAN concepts. Okay, so here what happens that it uses VLAN tagging. And what is the method is preferred for this tagging? 802.1q to differentiate between different VLANs on the same physical links. Okay, what happens with this particular VLAN tagging method? See, there are two methods for this VLAN tagging. Write down the two methods. What is VLAN tagging? Is a method of adding additional information about VLAN in the Ethernet header. There are two methods of doing this tagging. One is called as ISL, Inter Switch Link. Huh?
As an Indian super league. Is it?
Inter Switch Link. This is Cisco feature. It means this is applicable with the Cisco devices. It adds extra 30 bytes of information. What it does, it adds extra 30 bytes of information. Inter switch link. That's why we don't prefer this. Yes, I'm talking about the real-time devices only. It can be any method. What you are sending here. Okay, see. So here it adds extra 30 bytes of information. Now, as here it is adding more numbers of information, so we don't prefer this. ISL is not preferred for the trunking purpose. What is being preferred? 802.1q. 802.1q is preferred for the trunking purpose. And it is IEEE standard. And it is applicable with all other different vendors of the devices, including Cisco. It adds extra 4 bytes of information. Right? So as it is going to add only 4 bytes of information, that's why we prefer this 8 in the Ethernet header. E standard. What is IEEE? Institute of Electrical Electronic Engineers. So we prefer what? This one, 802.1q standard. Okay. So here it says that VLAN tagging 802.1q is used to differentiate between the different VLANs on the same physical links. So VLAN frames are tagged with a VLAN ID to indicate which VLAN they belong to, and typically configured on a trunk port connecting the switches or routers to carry traffic for multiple VLANs. So for this take tagging. So what happens? It says here that when you are using a VLAN in network that have multiple interconnected switches, so the switches need to use VLAN trunking on the links between the switches. And VLAN trunking causes the switches to use a process called as what? VLAN tagging, by which the sending switch adds another header to the frame before sending it over the trunk. So it will add extra information, that is the VLAN ID information, and based on that only the transmission will take place. Now Cisco has supported two different trunking protocols over the years. One is ISL inter-switch link and one is IEEE 802.1q. Today, 802.1q has become the more popular trunking protocol where we use tagging method. So while both ISL and 802.1q each frame with a VLAN ID, the details differ, and 802.1q inserts an extra 4 byte of VLAN header into the original frame, that is called as a Ethernet header. Got? So in the Ethernet header, it is going to add what? Extra information regarding what? VLAN header. And that is of 4 byte in 802.1q. So I told you that this tagging will be preferred when we will be using which switches? Layer 3 switches. Okay. So same thing, just you remove the switches here. Now we'll take layer 3. Say this is a multi-layer switches 3560. Two multi-layer switch will take. Same process. Come to this switch one. CLR. Now you will tell me the commands. If no, enable config space T. What is the host name? S1. Now tell me the commands. Which VLAN? Then interface range. What is the range number? You can F012. Okay, and this is 345. Visual. So interface range from F01 to 2. Switch port. Switch port. Then again, interface range F032. Switch port, mode, access, then come this one. VLAN 10 name now interface range. What is that number? F012 2 first, then switch port mode, access, switch port, access, VLAN, then interface, range, F012, sorry, not 12, 3 to 5, 3 to 4, right? Switch port, mode, access, switch port, access, VLAN, 20. Then do show VLAN brief. Configured. Same thing here also. Do show VLAN brief. Then now if you have to enable the communication, what is required? Trunking. And as it is a layer 3, so tagging is also required. So come to this switch 1, then interface F06. Okay, directly if I will give switch port mode trunk, then what will happen? Let's see that. Switch port mode trunk I'm giving, whatever we were giving on the layer 2 switches. What it says? Command rejected. Why? An interface whose trunk is auto cannot be negotiated to a trunk mode. Correct? No? So for that, what is required? Switch port trunk encapsulation .1q. Switch port trunk encapsulation .1q and switch port mode trunk. Now it converted to trunk. Correct? No? So one extra command is required on a layer 3 switch, that is called as a encapsulation .1q. Clear? Do show VLAN brief. Right? This is all information we have. Now show, do show trunk. Exit. Show interface trunk. Yes. So if you have given here show interface trunk, what it says? Port number F06, mode is on, encapsulation.1q, and trunking is there. What is native VLAN? We'll come to that part. Clear? Understood? The command. Then show interface F06, switch port, trunk. Same, you can check it on this interface as well. Do show interface F0, 5 switch port. Fine. See, now it is trunk, right? So when again you will send the traffic from this PC to that PC. So ping to 10.0.0.4. What will happen? It will ping? No. 4 is in different VLAN, no. I told you, no. L2 switches does not enable the communication between different LAN. See, why we are doing here tagging? On this layer 3 switches, we are doing this tagging to add extra header information. So we are informing this switch that, see, if you're getting the information from 10, send it to the 10 only. Why? We know he has the capacity to send to 20 also. Why? Because this is layer 3 switch. And layer 3 switch can enable the communications between different LAN. So here it has the capacity to send the traffic to different LAN. That's why we are telling him that don't send it. You have to send it to only same VLAN. But on layer 2 switch, we don't give this information. The reason, because we know by default, layer 2 switches does not have the capacity only to send the traffic to different VLAN. So why to give in extra information to him? Got it? Got no?
Layer three.
Huh? Layer 3 switches will be acting as a router. So it can have the communication between different LAN. So if it has the capacity to send the traffic between different LAN, so we need to specify one information over there that if you're getting information from this LAN, send it to the same LAN only. Do not send to other LAN. That's why. Got the idea? So you can write it here. Trunking command. Trunk command on layer 3 switch. Interface number, switch port, trunk, encapsulation dot 1Q. Switch port, mode, trunk. Clear till here? Yes, one more we have that is called as a native VLAN. So what happens with the native VLAN? See, it says that in the 802.1Q standard, any traffic that is advertised or received on a trunk port without 802.1Q VLAN tagging is associated to the native VLAN. If like you don't have to add extra header information, okay, using 802.1Q, for that we will be preferring here native VLAN, and by default the native VLAN is having a VLAN number 1. This means that when two switches, one is access port configured as an access port and associated with VLAN number 10, can send the traffic to VLAN number 10 only without tagging also. For that, this command is required. Switch port, trunk, native VLAN and VLAN ID. Just only one line you can remember here, that in this tagging is not required. Native VLAN is used to have the communication between two different VLAN without tagging. Okay, see, if I am giving here one information about that, so tagging is done, no? Here, tagging is done. Now let's consider that we will take one more PC here. And this side also one more PC. Okay. So we'll configure one IP 10.0.0.10. And here we'll configure one IP 10.0.0.10. Okay. Now, these two PCs are a part of one VLAN. Let's consider that it will be a part of. No, not VLAN number one. VLAN 100. Okay, and this is also VLAN 100. Now what will happen? You have to configure this IP over here. Desktop IP configurations 10.0.0.10. Okay, this is 11 now. This is going to be desktop IP configurations 10.0.0.11. Now come to the switch. Interface F07. First you tell VLAN number 100. Then interface, or what can also give name is native. Okay. Now interface F07. Switchport access. Switchport mode access. And switchport access VLAN number 100. Done. Now come here. VLAN 100. Name is native. Then interface. What is interface number? 6. 6 no. Switchport mode access. Switchport access VLAN number 100. Keep exit. Now here we will not be doing here trunking, right? So we will be using what? Native VLAN. What is the command for that? Switchport trunk native VLAN and VLAN ID. Switchport trunk. Okay. Come to this one. Give interface F06. Switchport trunk native VLAN. And what is the VLAN number? 100.
Interface 07.
Okay. Why it is showing you mismatch? Because we have not configured that side. That's why. Here also you do it same thing. On interface F05, no? This is 5. This one. Switchport trunk native VLAN number 100. Keep exit. Yes. Okay. Now it formed. And you verify. Do show VLAN brief. So one more we have as a native F06. And try to ping it from here to there. Ping to 10.0.0. It is pinging by same VLAN. No, that's why it is pinging. So here what happened? That you have configured, but you have not used here tagging. But this is which switch? Layer 3 switch only. No tagging we have done. We have not given a tagging method, right? For this interface, we have not done tagging. That's why it is sending it as like a native VLAN. So native VLAN by default is a part of which VLAN? VLAN number 1. Okay. When you will configure, then you are configuring it as like a native, and here extra header will not be added. When you will come to SNP switching part, in the EVNG, I will show you the same thing, but there I will capture the packet using WireShark. When I will capture the packet using WireShark, I will show you that when the information is sending from VLAN number 10 to 20, header information will be there. But when you will send it from the 9 this PC to this PC using native VLAN, no extra header will be required. But then this is called as what? Native VLAN, where extra header information is not required. That's why it is telling you that default native VLAN is what? VLAN number 1. Note it down this point. Native VLAN is used. Huh? Huh. There also we can do. Huh. But here you know that their header is not required. That's why we will be preferring here only. So native VLAN is used to enable the communication between the VLAN without tagging. By default, native VLAN is VLAN 1. Now for you one assignment, as you have 4 days holiday.
4 days.
So you have to search about the native VLAN, like in which case, okay, that is fine that it is not going to have tagging. Without tagging it is. So what are the scenarios and what are the advantage this native VLAN is providing us? We have different VLAN information where tagging is done, right? So what is the advantage I will be getting here? So you have to search about that and you have to write multiple regions. Okay, and the next class I will see and I will discuss. Is it clear till here? Clear it is? This week completes VLAN.
We have Inter-VLAN also, right?
Yes, we have Inter-VLAN. Now we'll start Inter-VLAN. Any questions, any doubt in the VLAN part? All done, guys, any question?
No, sir.
Okay, see what happens. That, for example, you have taken here one switch. And 2 PCs you have taken, right? This is switch. And this is PC1. And this is PC2. PC1 is a part of one VLAN. And PC2 is a part of different VLAN. This is going to be VLAN number 10, or you can consider, yes, VLAN number 10 only. Or let's say 100. And this is a part of VLAN number 200. Okay, now you tell me that this is a switch. With this, we have taken two PCs, PC1 and PC2. PC1 is a part of VLAN 100 and PC2 is a part of VLAN number 200. Now will they communicate?
No, sir.
Why?
So different.
Okay. If I'm giving it one as a IP 10.1.1 and second one I'm giving it as a 10.1.2. Is it correct? Huh? No, not correct. The reason we have, if you want to enable the communications between different VLAN, then you have to change the network address. The reason, understand here. Okay, if PC1 and PC2 wants to communicate, in this it is in 100, it is in 200. It means this is in the two different network. When devices are in the two different network, what do you use? Router, or we can use layer 3 switch also. Let's consider I am using a router. If I am using a router, so PC1 requires default gateway to communicate to the devices outside its own network. What is required? Default gateway. PC2 will also require the default gateway. If both the PC is in same network, then how you will have the communications? Right? No. Again, you will use only one default gateway. How it will be possible then? If they are in the different VLANs, they need to have a different network also, no? So that we can have here two different default gateways. Getting? So it means here I will change the network address. I will put here 10.2.2.1. Right. Now we'll take a router here. Now, for example, if I have taken one router and we have taken here one interface only. Now you tell me one thing, that this is my one interface. Let's consider 0/0. Okay. So I have PC1, I have PC2. PC1 is VLAN number 100 and PC2 is VLAN number 200. It means I require here how many default gateway? Two. How many interface you have? One. How you can create two different default gateway on a single interface? Right? There's problem. So for that, we will be using one method. The method is called as a router on a stick method. What is this method? Router on a stick method. This method is called as. So what we are discussing now, Inter-VLAN. So first you will write Inter-VLAN is used to enable the communication between the devices located in different VLAN. Okay. Now in this we have one router on a stick method. In router on a stick method, on a single interface of the router, we will create subinterface. Subinterface. And the IP configured on the subinterface will be acting as default gateway for the PCs located in different VLAN. It means here what will you do? That you will further divide this single interface into two different interfaces. Like how? Like G0/0/.1 and G0/0/.2. One is for VLAN number 100 and 2 is for VLAN number 200. We can go with any number, .1, .5, .6, anything. But here I have taken as a 1 and .2. So I have a single interface, and here what I am doing here, I can create sub interfaces. Understood this? So let me show you the configuration part now. Take one switch. So here, as we are going to connect end devices only, so we will be taking here in layer 2 switches. 2 PCs. IP is what? 10.1.1.1/24. This side 10.1.1.2/24. This is VLAN number 100. And this is VLAN number 200. Two different VLAN, right? Okay. By mistake, I have taken same IP. So we have to change that. So it is going to be 10.2.2.1. Okay. Next, you come to this switch now. Okay. Before that, come to this PC. Take one router only first. Okay. So on this interface, I have to create sub interface. We'll do it later on. First, you come to this switch. Enable config space T. Now, this is a layer 2 switch, so we can give it a host name as a layer 2. Then first you need to inform the switch regarding the available VLAN on these switches. What are those? 100 and 200. So VLAN 100, as I told you that this is not mandatory to give the names, so this time I don't give the name. And one more is what? VLAN 200. Then two VLANs we have. Now we will associate the interfaces with that particular VLAN. So interface number that we have here is F01, right? F01 is the interface number. Then switch port mode access. Switch port access VLAN 100. Then interface number F02 switch port mode access switch port access VLAN number 200. Configure this. Okay, now here it is fine. Now, don't you think that between this switch and this router, trunking is required? Because these are the two different VLANs, no? So here it has to send two different VLAN information to have the communication. So between them, trunking is required. And you also know that when we are using inter-VLAN concept, their trunking is required between the switches and the router. So interface F03, what we will do? Trunk. This is which layer switch? Layer 2. So what command I will give? Switch port mode trunk only. Tagging is not required. Then give here switch port mode trunk. That's all. On the switch, this is the command. Do show VLAN brief, and this we have configured, and also we have associated the interface. Right? Now, next command we have to give it where? On the routers. So come to this router, CLI, give no, enable. First, you make this interface as up. So come to config space T and give interface G0/0 and give it here no shut and give here exit. Now the interface is up. We have to create here what? Subinterface. So you will give here interface G0/0 dot and give a question mark. So these many numbers I can use to create the subinterfaces. Okay. So for this, I will be using here interface G0/0 dot 1. Okay. Now this dot 1 that you have created is for which VLAN? 100. So you have to inform this router that okay, that this particular dot 1 that I have created is for VLAN number 100. So for that you will give a command encapsulation dot 1q, and when you will give a question mark, it is telling you to give here what? VLAN ID information. What is the VLAN ID information? 100. Then after that, then you will assign one IP address on this particular subinterface. And this IP address would be of the same network of the VLAN number 100. So IP address 10.1.1. See, already one I have given to this PC, so we can take it 2 here. And 255.255.255.0. And already I have given here no shut, so again it is not required. So you can give here exit. So this particular IP, that is 10.1.1.2, will be acting as a default gateway for the PC located in the VLAN number 100, irrespective of the number of PCs. Here I have taken one PC only. I can have 10 PCs also, 15 PCs also, 20 PCs also. For all that 20 PCs, part of VLAN number 100, this is the default gateway. Right? Clear? Next, for the 200, what will you give? Interface G0/0, again dot 2. Then encapsulation dot 1q, and this is for which VLAN? 200. Again, one IP address 10.2.2.2, because already one I have given to the PC. Then 255.255.255.0 and give exit. This is the command. That's all. Now come to this end device, desktop, IP configuration. What is IP? 10.1.1.1, 255.255.0, 10.1.1.2. Now come to this one. 10.2.2.1, 255, 255.0. And what is default gateway? 10.2.2.2. They both are in different VLAN. Come to this PC1 and try to ping to PC2. 10.2.2.1. Communicating? Yes. Okay, 25% loss because of ARP request. So now the devices in different VLAN is able to communicate using which method? With inter-VLAN using a router on a stick method. So write down the command for this. See, I don't think that command for switches is required. Already you know, same command. Already we have written here. Right? So I will give the command for the router only. So on router, you will give interface. Let me write the example with example only, okay? For example, interface G0/0, then .1, encapsulation, .1Q, and VLAN is 100 for this. Then IP address we have given here, 10.1.1.1, 255.255.255.0, and give exit. And before that, you have to remember that you have to make this interface as up. So before giving all these commands, you make interface G0/0 as no shut. Then one more, interface G0/0.2 and encapsulation .1Q. And what is the VLAN ID here? 200. Then IP address 10.2.2.1, 255.255.255.0. Okay, check it. Change it here. This is 2 and this is 2. Right. And then give here exit. This is the first method, router on a stick method.
So what is the maximum number of subinterface that we can create?
So that when I have given the question mark, would have seen that many numbers that we have. So we can
Yes,
go
yes.
with the multiple ranges. We can create multiple subinterfaces. No as such limitation. Clear, no?
Yes, sir.
And even it depends upon the series of the router. So whenever you are going with subinterface, so you write the interface number dot and then give a question mark. It will show you the numbers that you can use there.
So what is the scenario when we are using a layer 3 switch?
That is only the next we are going to discuss. So now here we have taken here layer 3 router. If we, instead of taking this router, we can also use here layer 3 switches. And that is called as a SVI, switch virtual interface. Okay. One more method, Inter-VLAN, using SVI, that is switch virtual interface. Now in this, what will happen that instead of taking router, we will be using here layer 3 switch. In this method, layer 3 switch will be used to enable the communication between the devices located in different VLAN. Okay. In this, IP address will be configured on interface VLAN, not on the physical interface of the switch. Do you know you cannot assign the IP on the physical interface of the switch? You cannot assign. Even if you will give, it will give you command invalid input detected. If you want to assign the IP IP on the physical interfaces of the switch, for that you have to give a command on that interface number, no switch port. If you will give no switch port, then only you will be allowed to configure the IP on the physical interface of the switch. And in Cisco packet tracer, it will not work. It will work in the EVNG or the real devices. So here, that's why what we are going to do, we will be configuring the IP on the interface VLAN. So one group is there, no? VLAN number 100. So we will be configuring the IP on the interface VLAN number 100. And that IP will be acting as a default gateway for the PCs located in the interface VLAN number 100. Right? So see the configuration part now. Same process is there, whatever we have done till now. So in this only we can remove this router. And now what we will take? A layer 3 switch. See, the command that we have given on the layer 2 is fine, right? Same command is required. Whatever what we have given, first we need to inform that the switch is having VLAN number 10 and 100 and 200. Done. Then you are giving here what? Which interface is having 100 and 200. And then you have done the trunking here. Just difference is that here you have done mode trunk. Only one command you have given mode trunk. This time we are using here layer 3 switches. So we need to configure here what? Encapsulation also, right? So now we will come to layer 3 switch, CLI, give no, enable config space T, host name is what? Layer 3. Now, as this is a layer 3 switch, so it understands the VLAN information. So we can tell that you have two VLAN, 100 and 200. Right? But that VLAN is not directly connected with this layer 3 switches. That's why no need to give interface information. What you will give interface number? F03, sorry, F01. F01 is there, no? Switch port, trunk, encapsulation dot 1Q, switch port, mode, trunk. Then trunking is done. Then what we have to do here, we have to configure the IP that will be acting as a default gateway. So where you have to configure interface VLAN number 100. On the interface VLAN only, I'm going to configure the IP. Interface VLAN number 100. What is the IP? 10.1.1.2. Already we have given this one. That's why 255, 255, 255.0. Give exit. Then interface VLAN number 200. IP address 10.2.2.2.255.255.0. Give exit. Done. I will verify do show IP interface brief. So no IP is there on any of the physical interfaces. Check at last. Yes, this is there. Correct. Now, if you will try to ping, already we have configured the IP on the PCs, and even we have the default gateway, so no need to do again. Just you to come to command prompt and ping to 10.2.2.1. What will happen? It will ping. It should ping. Inter-VLAN we have done. So devices into different VLAN has to communicate. But it is not communicating. The reason? Because as of now, this layer 3 switch is acting as a switch only, not as a router. So at last, you need to give one more command on the layer 3 switch. That is called as a IP routing. Okay. If you have given this IP routing command, then again you ping. Pinging. Yes, it is pinging. Got? This is switch virtual interface. Write down the commands for this. And you know what we have to configure on the layer 2. Two methods we have discussed. One more method is there. Router using multiple physical interface. So you will try that. Okay. So I will give you one scenario. You have time, so you will try that. And then we'll discuss in the next class this last one. Okay. So same scenario, you can take it. Just what we'll do, we'll remove this, and I will take a router. And this time, instead of using this only one interface, I will be using here two different interfaces. Okay. See, first we need to discuss this one only. The reason, because you know that on a router, we may have multiple physical interfaces. So instead of using sub interfaces, I can have this multiple interfaces, right? So where one interface, that is G0/0, will be acting as a default gateway for the PC in VLAN number 100, and G0/1 will be acting as a default gateway for the PC coming under VLAN number 200. But why we use router on a stick method? The reason, because you know that it is not that always we will be having 2 or 3 different VLANs. We may have more than that also, right? And you know that router is going to have limited number of ports. So always it is not possible for me to have multiple different ports for multiple different VLANs. That's why the most efficient way is to use router on a stick method, right? But if you have 2 different VLANs, so you can go with this method also, where we use multiple physical interfaces. Okay, so this is your task. Okay, note down this. You will configure and you have to enable the communications between the devices in VLAN number 100 and VLAN number 200. All the concepts remain same. You try. No, you can try it later on. We'll discuss in the next class this concept. Okay, here encapsulation is not required. Just it is very simple. You just have to configure the IP, do the trunking, and even trunking is also not required. When trunking is required? When that single link is going to carry multiple multiple VLAN. Here I have single link, no? And this single link is for VLAN number 100, and this single link is for VLAN number 200. That's why. Okay, you will try this. We'll discuss. Fine. Okay. So we have completed VLAN and inter-VLAN. Next class, we'll discuss this one. And then we'll start with DTP, Dynamic Trunking Protocol. And then we'll start with the VTP, VLAN trunking. Clear? We'll stop the recording.